So, good morning, students. Myself, Professor B.B. Ingle, and today we have to discuss the lecture number 6 of unit number 2. The name of the subject is NCES. So, in previous lecture, discussion about the flat plate collectors. Okay. Then today we have to discuss the evacuated tube collectors. Okay. So, what is the definition? Evacuated tube collectors are made up of a single or multiple rows of parallel transparent glass tubes supported on a frame. This sealed copper heat pipe transfer the solar heat with convection of its internal heat transfer fluid to a hot bulb that indirectly heats up a copper manifold within the heater tank. So today our discussion on evacuated tubes. If you consider this one, guys, this is called as the evacuated tube collectors. If you consider this much diagram, so this is the diagram of the evacuated tube collectors. Okay, and generally nowadays all the type of the solar water heater system use this evacuated tube collectors. Yes or no? Yes. So you see here. So in evacuated tube collectors, if you observe in diagram, so what is the components? So this is the vacuum will be theirs. This is the vacuum. This is the copper U tube bend tube. This is the solar radiation. The solar radiation incident on these collectors. Okay. This is the inlet of the cold water. This is the circulation of a cold water. After absorbing the solar radiation, the temperature will be increases. This high temperature liquid is travel through the tubes, and from this section the hot water will be get out, and from this there is a vacuum will be provided. Why vacuum will be provided? To avoid the heat loss by convections. So to avoiding the heat loss by convection, the vacuum will be provided. This vacuum prevent the heat losses from system to surroundings and increase the heat transfer rate, means to absorb the lot of radiation absorption, but reflection is less, heat loss will be less by the use of the vacuums. So let's we discuss here. So evacuated tube collector, ETC, means nothing but the evacuated tube collectors. Use a rows of a glass tube, each of which contains a heat pipe collector with a heat transfer fluid surrounded by a vacuum which greatly reduce the heat loss. Yes or no? Yes, this is the glass tube. There is this heat pipe. If you consider the observer is this one, there is a insulation will be there. Okay, and this is the collection of tubes. So it provides the temperature up to how much? 120 degrees Celsius, means more than flat plate collector. More suitable for use in cold climates. With the use of inert gas or ultra high vacuum, the temperature can be increases up to the 150 degree Celsius, guys. So let's we discuss the parts of evacuated tube collectors. If you consider in this diagram here, if you observe the one portion of the evacuated tubes, so this is the what is the solar radiation. Both the type of the radiation will be come out from the sun beam as well as what is diffuse. This radiation incident on this evacuated tubes. This is the absorber. The absorber solar radiation hit the fluid which vaporizes and rises to the top of the tube. Now, this portion is the heat pipe which carries the fluid. Okay. This is the cooled or condensed liquid return to the bottom. This is the inlet portions. After absorbing the solar energy, the temperature will be increases and it will be rising in upward direction to this heat bulb. Okay, this bulb portions, and heat exchanges to the headers. So this is the heated liquid as a vapor rises to the top, and there is this vacuum will be provided in between the tube and this section. This vacuum is reduce the heat losses from system to surroundings. If you consider in this diagram also, guys, so this is the diagram of the evacuated tube collectors. This is the fluid enter in a tube. Okay, this fluid is circulated like that, and the fluid will be out, and this is the evacuated portions. This is the absorber plate with sealed surface. Because of this absorption, lot of radiation will be absorbed. If you consider in this way, section AA, if you observe in side view, this is the suppose top view, this is the side view. So observer plate with selective surface. These are the tube and this portion is observer plate and these are the solar radiations. Okay, this is in flat type. Another is in concentric type of the tube. This fluid is entered through this section. Whenever the fluid is entered, this hot fluid will be move in this way in both the direction, this direction and this. So we getting this fluid out, and there is a in between, there is a complete vacuum will be there. So because of this vacuum, there is no heat losses from system to surroundings. So this is diagram, this is the diagram. Okay, if you consider here is also, this is the diagram if you observe. This is the vacuum portions. Okay, this portion is vacuum. There is no only the solar radiation absorbed, but less rate of reflection from system to surroundings. So this is the vacuum portions. In between, this is the observer plate. This is the heat carrying fluid which is made by the copper, and the fluid is entered through the tube and we getting the very high temperatures. These are the components of this header pipe, manifold, heat transfer fin, evacuated tube, heat pipe, and this is the mounting frame. So look at here. So parts of evacuated tube collector. So evacuated tube collector means nothing. It absorbs the solar energy and convert it into the useful heat. A vacuum between the two glass layer insulates the against heat loss, right? जो वैक्यूम जो होगा दो ग्लास के बीच का वजह से क्या हो जाएगा, इंसुलेशन क्रिएट हो जाएगा और हीट को लॉस नहीं होने देगा. द हीट ट्रांसफर फिन्स हेल्प्स टू ट्रांसफर द हीट टू द हीट पाइप. मीन्स देयर इज अ यूज ऑफ दिस फिन्स विल बी देयर्स. द फंक्शन ऑफ द फिन्स टू इंक्रीज द मोर रेट ऑफ हीट ट्रांसफर टू द फ्लूइड्स. मीन्स हीट ट्रांसफर इज इंक्रीजेस विद द हेल्प ऑफ द फिन्स guys. Then heat pipe will be used there, the copper vacuum pipe that transfer the heat from within the evacuated tube up to the manifold. Then another is a manifold, insulated box containing the copper header pipe. The header is a pair of the counter copper pipe which dry connect the socket that heat up the pipe plug into, and another is a mounting frame. So overall very simple construction of this evacuated tube collectors. Very simple diagram, very simple constructions. Okay, and only the change, there is only the vacuum is provided. Because of this vacuum, the high temperature is gained by this evacuated tube collectors, guys. Okay, now another very important topic is what is now concentric collectors. So what is the definition you see here? This is very IMP. This question is always asked in exam. Explain the concentric collector. So concentric collector use a mirror surface to concentrate the sun energy on absorber called a receivers. Okay, concentrator perform the best when pointed directly at the sun. To do this, system are used to tracking mechanism to move the collector during the day to keep them focused on the sun. Single axis tracker move east to west and dual axis tracker move from east to west and north to south. Okay, they can achieve the temperature up to 400 degrees Celsius. So this concentric solar collector means to concentrate the solar radiation at a one point, or to concentrate the solar radiation at a one line. That is called as the concentric solar collector, and to achieve the temperature more than 100 degrees Celsius, that is called as the concentric solar collectors. And this classified into the, you observe here classification: parabolic dish collector, linear parabolic trough collector, linear Fresnel collectors. Okay, so first of all we discuss this parabolic dish collectors. Yes or no? Yes. This parabolic dish collector is nothing but another is a point type of collectors. Point type of collectors. Okay, so you see here, this is the solar radiation. This is the solar radiation which is incident on this parabolic dish, and from this parabolic dish which are reflected toward these receivers here. Yes or no? Yes. So this is called as the point type of collectors. So see here, the collector collect the solar energy coming directly from the sun. Okay, directly on the sun on this parabolic dish. The design is parabolic shape and dish type, that's why it is called as the parabolic dish collectors. Okay, and concentrate or focus it on the small area. अब ये जो एरिया है बच्चों, ये एरिया बड़ा है, इसका एपरेचर एरिया बड़ा बड़ा है और रिसीवर एरिया छोटा है, तो इसका कॉन्सेंट्रेशन रेशियो जो है मोर देन 1 होता है, 10 और 20. वी नो द डेफिनेशन ऑफ द कॉन्सेंट्रेशन रेशियो, द इट इज़ अ रेशियो ऑफ एरिया ऑफ एपरेचर अपॉन एरिया ऑफ रिसीवर. तो एपरेचर एरिया तो इसका बड़ा है, रिसीवर एरिया छोटा है, तो कॉन्सेंट्रेशन रेशियो जो इसका ग्रेटर देन 1 ही होता है. दैट्स वाई वी कैन गेटिंग द वेरी हाई टेम्परेचर्स. So the resultant solar beam has all of the power of the sunlight hitting the dish, but it is concentrated in a small area so that it can be more efficiently used. The glass mirror reflects the 92% of the sunlight hits them. This dish structure must track the sun continuously to reflect the beam into the thermal receivers. Yes or no? Yes. Means if you understand here, this one, if you understand here more better, parabolic dish system. A parabolic dish collector is similar in appearance to a large satellite, just like a satellite dish, but has a mirror like reflectors and observer at the focal point. Okay, it is use a dual axis sun trackers. Dual axis sun tracker means it is moving east to west or north to south. If you consider this diagram is here, this is the receiver area, this one is our, we know the aperture area. Okay, the solar radiation incident on this reflector, and from this reflector it is incident on this receiver. In this diagram, this is the reflectors, the solar radiation will be incident, and from this solar radiation incident on these receivers. Okay, parabolic dish collectors. Parabolic dish collector with mirror, reflector and absorber at the focal point. It is situated at the focal distance. Okay guys, so here a parabolic dish system uses a computer to track the sun and concentrate the sun rays onto the receiver located at the focal point in front of the dish. Okay, so in some system a heat engine such as Stirling engine is linked to the receiver to generate the electricity. So parabolic dish system can be reached 1000 degrees Celsius at the receiver and achieve the highest efficiency for converting the solar energy to electricity in the small power capacity range. Yes or no? Yes. So here we have to put the one Stirling engine, and the Stirling engine is produce the electricity guys here. Okay. So engine currently under the consideration include the Stirling and Brayton cycle engine. Several prototype dish engine system ranging size from 7 to 25 kilowatt have been deployed in various locations in USA. High optical efficiency, low startup loss make a dish engine or system the most efficient of solar technology. Stirling engine or parabolic dish system holds the world record for converting solar into electricity. Okay, in 1984, 29% net efficiency was measured in Rancho Mirge. So this is the simple explanation of this parabolic dish type. This is also the, if you observe here, the more diagram explanation. So parabolic dish system use a dish shaped parabolic mirror as a reflector to concentrate and focus the sun rays onto receiver, which mounted above the dish at the dish center. A dish or engine system is stand-alone unit composed a primary of a collector, receiver and engine. It works by collecting and concentrating the solar energy with a dish-shaped surface onto the receiver, absorb the energy and transfer it to the engine. The engine then converts the energy to heat. The heat then convert into the mechanical power in a manner similar to conventional engine by compressing the working fluid when it is cold and heating the compression working fluid. Okay, then expanding it through the turbine or with a piston to produce the mechanical power. A electric generator alternated convert the mechanical power into electrical power guys. So very simple explanation about this. So each dish produce the 5 to 50 kilowatt electricity and can be used independently or linked together to increase the generating capacity. मतलब एक भी यूज कर सकते हैं या फिर 10-12 जन को कनेक्ट कर लिया तो मल्टीपल पावर जनरेट कर सकते हैं. 250 किलोवाट प्लांट कंपोज of 10 or 25 kilowatt dish engine system require less than acre of land These engine systems are not commercially available yet, but although ongoing demonstration indicate the good potential. Individual disk engine system currently can generate about 25 kilowatt electricity, and more capacity is possible by connecting the dish together. This system can be combined with a natural gas, resulting hybrid provides continuous the power generations. Okay, guys. So this is the simple explanation about this parabolic dish system type of the solar collectors. Very simple, very simple construction. Guys, this parabolic dish. I saw the number of diagram. This one, this is the, means if you call this is the point focusing collector. This is our dish. Okay, simple, and this is the receivers. In this way, this is the parabolic dish, and this is a receiver. The solar radiation incident on this dish, then after that reflected toward the receivers. फिर यहाँ पे हम बच्चों स्टर्लिंग इंजन यूज़ करते हैं, फिर वो स्टर्लिंग इंजन रोटेट होने के बाद में पावर जनरेट होगा, वो कनेक्टेड रहेगा फिर जनरेटर को, जनरेटर प्रोड्यूस द इलेक्ट्रिसिटी, एंड दिस लॉट ऑफ थिंग्स विल बी गोइंग will be here's. Okay, so this is called as the explanation about the parabolic type of collectors. Here is also the number of the diagram. This one C number, this one parabolic dish, this is the dish, and this is the receiver, nothing but the absorber. Now another is the discussion in our part, this parabolic trough system, parabolic type, parabolic trough system. This first one is completed. Now we have to discuss the parabolic trough. These are the type of the concentric collectors: parabolic trough, parabolic dish, power tower, and stationary. So we now discuss the parabolic trough. So this one, parabolic trough. Okay, parabolic trough system. This is the diagram of the parabolic trough. So parabolic trough are a device that are the shape like the letter of U. Okay, U shape का इसका design है. The trough concentrates the sunlight onto the reservoir tube that position along the focal line of a trough. Sometimes transparent glass tube envelopes the receiver to reduce the heat loss. So this parabolic trough system, nothing but the line type of collectors, line type. Yes or no? Yes, in this diagram, if you understand. Here, this one. This is the parabolic trough collectors. This is the shape is U shape. The solar radiation incident on this U shape collector, and from this it is reflected toward this line type, and through this line the water is circulated, or our working fluid will be circulated. Its temperature will be increases, and then this can be used for to generate the electricity. In this way, you consider here. If you, and this is the, suppose a single track system will be used there. The solar radiation is incident on this parabolic trough. Okay, from this it is reflected toward this pipeline line type. The fluid is entered here, cold fluid. Then after means absorbing the solar energy, the hot temperature will be generated. Very high temperature means in the form of the steam directly, and this steam we can use for generation of electricity, guys. Okay, let's we discuss here in parabolic trough now. So parabolic trough uses single axis or dual axis tracking. So this figure, if you consider the one axis tracking parabolic trough with axis oriented east or west. Yes or no? Yes, if you consider here, means axis orientation only the east or west direction, means the one axis tracking parabolic with the axis oriented east or west. Another is a dual axis, means which operate in both the axis direction, east to west or north to south. This is the two axis tracking mechanism to concentrate the solar radiation in all directions. Okay. So temperature at the receiver can be reach how much? It is 400 डिग्री सेल्सियस टेम्परेचर ऑफ द वाटर, मतलब 400 डिग्री सेंट्रिकल का टेम्परेचर हमारे को पैराबोलिक ट्रक सिस्टम में मिलता है बच्चों, एंड प्रोड्यूस अ स्टीम फॉर जनरेटिंग द इलेक्ट्रिसिटी. ये टेम्परेचर पे वाटर तो डायरेक्ट कन्वर्शन हो जाएगा गाय के अंदर स्टीम के अंदर, and this steam we can utilize for generation of electricity. So in California, multi-megawatt power plants were built up using the parabolic trough combined with the gas turbines. So parabolic trough combined with the gas turbine as shown in figure. If you look at these figures, okay. So cost projection for the trough technology is higher than those for power towers or disk engine system due to the large part of the lower solar concentration and hence lower temperature and efficiency. However, with a long operating experience, continue technology improvements and operating and maintenance cost reduction, trough are least expensive, most reliable solar thermal power production technology for a near term. If you explain more detail in a trough system, this one, this is the solar collector. Use a mirror parabolic trough to focus the sunrise to fluid carrying receiver tube. Okay, this is the parabolic trough our located at the focal point of the parabolically curved trough reflector is shown in figures. Okay. The energy from the sun sent to the tube heat up the oil flowing through the tube. जो उसमें का जो ट्यूब में से जो ऑयल है जो पास होगा वो हीट हो जाएगा and the heat energy then used to generate electricity in a conventional steam generators. Many trough placed in parallel row called collector field. The trough in the field are aligned along a north-south axis so they can track the sun from east to west during the day, ensuring that sun is continuously focused on the receiver pipe. Individually, the trough system currently can generate about 80 megawatt of electricity. Yes or no? Yes. And trough design can incorporate thermal storage setting aside the heat transfer fluid in its hot phase, allowing for electricity generation. Several hours into the evening, and currently all parabolic truss plants are hybrids, meaning they use a fossil fuel to supplement the solar output during the periods of low solar radiation. Typically, a natural gas fire heat or gas then steam boiler reactor is used. Trough can also integrate with the existing coal fire plants. So these are the very detail. इतना तो आपको पेपर में लिखने की कोई आवश्यकता नहीं बच्चों, सिर्फ एक सिंपल डायग्राम निकालना है and you explain this diagram. Only the very simple diagram. ये डायग्राम आपको निकालना है, ये डायग्राम को आपको एक्सप्लेन करना है. मतलब पैराबोलिक ट्रफ हमारे पास में एक बीच में एक सेंट्रल लाइन दी है. सोलर रेडिएशन ये पैराबोलिक ट्रफ के ऊपर इंसिडेंट होंगे, यहाँ से रिफ्लेक्ट होंगे, ये ट्यूब के ऊपर स्ट्राइक होंगे. एक ट्यूब में से हम एक फ्लूइड सर्कुलेट करेंगे. सपोज वाटर इज सर्कुलेटेड, देन कन्वर्शन ऑफ द वाटर इनटू द स्टीम and this steam is utilized to run the turbine and generation of electricity. So this is the explanation about the parabolic dish type. Now another is a discussion of power tower system, very important this one also. The name is central receiver system. The another name is central receiver. I show this diagram, this one central receivers. Okay, power diagrams. I show the another diagram to you. This one also, this diagram, third diagram, this D number, central receiver system with a heliostat. अब ये छोटे छोटे जो मिरर यहाँ पे दिख रहे बच्चों, इनको कहते हैं हम हेलियोस्टैट. ये पूरे के पूरे हेलियोस्टैट कहाँ लगे रहते हैं, ये पूरे ग्राउंड पे कनेक्टेड है. एंड दिस इज द आवर टावर, और ये टावर के ऊपर हमने एक रिसीवर रख दिया, ऑब्जर्वर रख दिया. दैट्स व्हाई इट इज कॉल्ड एज द सेंट्रल रिसीवर सिस्टम विथ अ हेलियोस्टैट. ओके, दिस इज अ सेंट्रल रिसीवर, मतलब इसके सेंटर पे और टावर पे हमने ये रिसीवर रख दिया है. अब सोलर रेडिएशन जो है ये हेलियोस्टैट पे इंसिडेंट होंगी. हेलियोस्टैट का शेप जो है वो रेक्टेंगुलर शेप का है. जब सोलर रेडिएशन इसके ऊपर इंसिडेंट होंगे तो यहाँ से रिफ्लेक्टेड होंगे, ये रिसीवर पे जाके स्ट्राइक होंगे. ये रिसीवर में हमारा वर्किंग फ्लूइड रखा है. द टेम्परेचर ऑफ द वर्किंग फ्लूइड विल बी इंक्रीजेस एंड दिस विल बी यूज फॉर जनरेशन ऑफ इलेक्ट्रिसिटी गाइस. यस और नो? यस. So let's we discuss this now very detail. If you consider this is the diagram, ये डायग्राम दिख रहे बच्चों, ये जो ग्राउंड पे लगे है सब ये हेलियोस्टैट है. ये हमारा टावर है, ये जो दिख रहा है आपको, दिस इज द टावर. और ये सेंट्रल में हमने एक रिसीवर रखा है जो सोलर रेडिएशन को क्या करेगा, ऑब्जर्व करेगा. सब रेडिएशन इसके ऊपर रिफ्लेक्ट होंगे, सन से ऐसे इंसिडेंट होंगे, यहाँ से रिफ्लेक्ट होकर इसके ऊपर आएंगे. So you see here, a heliostat use a field of dual axis sun trackers. अब जो नीचे जो ये हेलियोस्टैट लगे ये ड्यूअल एक्सिस है, मतलब ईस्ट वेस्ट में भी रोटेट होंगे और नॉर्थ साउथ में भी रोटेट होंगे. दीज आर द हेलियोस्टैट. इफ यू ऑब्जर्व हियर द रेक्टेंगुलर शेप, दीज आर द हेलियोस्टैट. और यहाँ पे ये ड्यूअल एक्सिस सन ट्रैक है, मतलब सन को ये चारों साइड से ट्रैक करेगा. ओके, दैट डायरेक्ट द सोलर एनर्जी टू अ लार्ज ऑब्जर्वर लोकेटेड ऑन अ टावर्स. दिस इज अवर ऑब्जर्वर सिस्टम और रिसीवर which is placed at the tower. So to date only the application for the heliostat collector is a power generation system called as a power plant. और यहाँ पे हमको टेम्परेचर भी बहुत ज़्यादा मिलेगा, वेरी हाई 70 डिग्री सेल्सियस टू 1000 डिग्री सेल्सियस टेम्परेचर विल बी जनरेटेड इनसाइड द सेंट्रल रिसीवर सिस्टम और पावर टावर सिस्टम. A power tower has a field of a large mirror that follow the sun path across the sky. The mirror concentrates sunlight onto the receiver on the top of the high tower. Here, a computer keeps the mirror aligned to the reflector rays of the sun are always aimed at the receiver, where the temperature well above the 1000 degree Celsius can be reached. High pressure steam is generated to produce the electricity. The power tower system with a heliostat as shown in figure. This is the figure. Okay. We expand a more detail now. So look at here. A central receiver or power towers use the thousands of individual sun tracking mirror called as the heliostat to reflect the solar energy onto the receiver located at the top of the tall tower. Yes or no? Yes one. This one. This is the heliostat which absorb the solar energy and reflected on this top of the receiver or absorber. Yes or no? Yes. The receiver collect the sun heat in a heat transfer fluid that is called as the molten salt. The molten salt will be used here. Molten carbonate or sodium carbonate is used here. Means this is the working fluid used in tower type. Why? Because it has a very high boiling temperature. That's why we can use this molten salt here. That flow through the receiver. The salt heat the energy then used to make a steam to generate electricity in a conventional steam generator located at the foot of the towers. The molten salt storage system retain heat efficiently, so it can be stored for hours or even days before being used to generate electricity. So in this system, molten salt pump from a cold tank at 288 degrees Celsius and cycle through the receiver where it is stepped up to the 560 degrees Celsius and return to the hot tank. The hot salt can then be used to generate the electricity when it needed. Current design allow the storage from 3 to 13 hours. मतलब देखिए बच्चों, यहाँ पे क्या होगा कि जब ये हॉट हो जाएगा मोल्टन सॉल्ट, तो दिस हॉट मोल्टन सॉल्ट इज स्टोर इन दिस टैंक. Then after that, where is pass? It is pass inside the steam generator. So inside the steam generator means there is an indirect system. There is a circulation of the water. The water is converted into the steam, and this steam is strike on the turbine, and turbine produce the electricity, guys. Then after that, the steam is condensed inside the condenser. Then after that, once again the steam will be used. लेकिन ये जो मोल्टन सॉल्ट आ गया, ये हीट ट्रांसफर कर देगा ये स्टीम को. उसके बाद में उसकी हीट लॉस हो जाएंगी, टेम्परेचर कम हो जाएगा, तो ये कन्वर्ट हो जाएगा कोल्ड स्टोरेज में ये मोल्टन सॉल्ट, और ये वाले टैंक में जाके स्टोर हो जाएगा. यहाँ पे हम उसको पंप का यूज करके ऊपर सप्लाई कर देंगे रिसीवर के अंदर. मीन्स दिस कोल्ड मोल्टन सॉल्ट इज पंप इनटू द रिसीवर्स, and then the receivers is absorb the solar radiation from this heliostat is continuously. Once again its temperature will be increases, then transfer into the this hot storage tank. Then from this hot storage the heat is exchanged with the water is converted into the steam, then steam is strike on the turbine and generation of the electricity. So in this the process will be happen here in a molten salt storage or a central receiver system, guys. अब हमारा लास्ट कलेक्टर बचा है, दैट इज कॉल्ड एज द फ्रेस्नेल लेंस कलेक्टर्स. तो वेरी सिंपल दिस वन, दैट इज कॉल्ड एज द स्टेशनरी कॉन्सेंट्रिक कलेक्टर्स. मीन्स दिस वन, मीन्स वी कंप्लीट दिस A, C and D, and now this is the our last one, what is a linear Fresnel collectors. So this is also very simple, guys, this one. So here what is the component? There is a reflector at the center, there is a absorbing tube, and there is another is what is this secondary reflectors. So what happen here, from the sun the solar energy is incident on the this reflector. From this reflector this solar energy strike where on this central receiver pipe, and this pipe is carries the working fluid and which get the heat energy, and very high temperature will be generated, and this high temperature fluid means just like as a steam we have to get, and this steam we can use for power generations. And there is also the another secondary reflector will be used, means this radiation suppose is incident is here, so from this portion the once again the reflected back is here, so that is called as the Fresnel lens type of collectors. This one means inside means there is a this observing tube, and surrounding there is a number of the reflector, that's why it is called as the linear Fresnel collectors, guys. Then along with this one, if you observe, here is also in another linear Fresnel collector. So linear Fresnel reflector approximate the parabolic shape of trough system, but using a long rows of a curved mirror to reflect the sun rays onto the downward facing linear and fixed receiver. मतलब यहाँ से तो सन एनर्जी रिफ्लेक्ट हो जाएंगी, बाद में ये यहाँ पे जाके पैराबोलिक रिफ्लेक्टर के पे जाके एक ट्यूब पे स्ट्राइक होंगे, वो ट्यूब के अंदर से जो वर्किंग फ्लूइड फ्लो होगा उसका टेम्परेचर राइज होगा. द मेन एडवांटेजेस इज दैट देयर इज सिंपल डिजाइन ऑफ फ्लेक्सिबिलिटी बेंड ऑफ मिरर्स एंड फिक्स्ड रिसीवर require the lower investment cost and facilities direct steam generation, eliminating the need for heat transfer fluid and heat exchange. Yes or no? Yes. So this is the simple explanation about the concentric solar collector, guys. Okay. Then apart from this we have the another concentric collector. This one I show this image to you now. This is also the modified flat plate collectors, non-focusing. This is our flat plate collectors. To increase the more efficiency, we have to connect it. This mirror will be there in this diagram. This is the flat plate collector. These are the reflector will be used. So flat plate collector is incident, means there is solar energy on this collector. Then after that ये सोलर एनर्जी ये रिफ्लेक्टर के पे ऊपर इंसिडेंट होंगी, फिर यहाँ से रिफ्लेक्ट होके ये बाद में जाके हमारे ऑब्जर्वर प्लेट पे भी इंसिडेंट होंगी इन दिस वे, इन दिस वे, इन दिस वे एंड इन दिस वे. दिस इज द मॉडिफाइंग ऑफ अ फ्लैट प्लेट कलेक्टर्स. This another is a compound parabolic collectors. In compound parabolic collector, how many? There are two parabolic collector will be used. That's why it is called as the compound parabolic collectors. And this is our observer. So solar radiation is incident on this collector, and from this after that, suppose the solar radiation incident on this parabolic collector, and from this parabolic collector it is incident on this observer plates. In similar way, the solar radiation will be incident on this parabolic collector in when the sun in different position in the sky. Then after that, once again it is reflected on this observing surface. So that's why it is called as the compound parabolic collectors. Compound means more than two parabolic system used. That's why it is called as the compound parabolic collectors. Okay. So this is the end of unit number 2. So I stop here, guys. In next lecture, we will be discuss the unit number 3, solar energy applications. So stay at home, stay safe. Thank you very much.